5 layers stand between you and the center of this planet. One kills you in under a second, another takes almost 20 minutes. By the end of this video, you'll know which one, and it's not the one you're thinking of right now. You're separated from the most hostile environments in the solar system by a few kilometers of rock. Let's say you had a drilling capsule tough enough to punch straight down to the center. Layer 1 starts now. Layer 1, the crust. You start where every human who has ever lived has spent their entire life. No material we've ever built could actually make this trip, not steel, not titanium. So let's assume your capsule is some hypothetical alloy that buys you a little extra time before the planet wins anyway. It sounds solid. It sounds safe. It's actually the thinnest layer of the entire planet, more like the skin of an apple than anything substantial. Only 5 to 10 kilometers thick under the oceans and 30 to 50 under the continents. Humans have only ever drilled 12 kilometers down. The Kola super deep borehole in Russia, a project that took almost 20 years before the rock got too hot to continue. Engineers expected 100 degrees Celsius down there. They hit 180 instead. That's the first lesson of this trip. The deeper you go, the more the planet breaks its own rules. But heat isn't what gets you first. It's the pockets. Buried gas and superheated water, sealed under millions of years of pressure with nowhere to go. And your capsule is about to drill straight into one at random. Hit it wrong and it doesn't crush you, it detonates, flashing to steam fast enough to tear the hull apart from the inside before you even register the impact. Survive that roll of the dice and you're already deeper than any human structure has ever gone. The rock itself keeps changing too. Granite giving way to darker basalt the further down you go, the walls slowly starting to flow instead of crack under the weight. And this is the easy layer. Layer 2, the upper mantle. Break through the crust and everything changes. The mantle alone makes up 84% of the planet's entire volume, so much bigger than the crust that, if the crust is the apple's skin, this is the entire fruit underneath. Temperatures are already past 500 degrees Celsius, hot enough to soften metal in minutes. But the real danger here isn't the heat, it's the ground itself turning against you. You hit the asthenosphere, a layer that isn't solid and isn't liquid, oozing like thick tar over thousands of years. This is what the continents float on. Every earthquake that has ever leveled a city started as a shudder passing through the exact space you're now drilling into. Keep going and temperatures pass 1,000 degrees Celsius, but it's the pressure that actually ends you, closing in from every direction until your hull folds like a can underfoot. At 410 kilometers down, you hit the transition zone, where pressure is so extreme it rearranges minerals into crystal structures that don't exist naturally anywhere near the surface. Strange greenish formations under your capsule's lights that no human eye has ever actually seen. Every reading your instruments send back at this point is a genuine first, numbers no scientist on the surface has ever directly measured. And here's the part that should worry you. You're still not even halfway there. You haven't even reached the layer that generates most of the planet's raw geological violence yet, and it's about to get much, much worse. Layer 3, the lower mantle. This is where survivable stops being a real word. The lower mantle alone stretches almost 2,900 kilometers, more than twice as thick as everything above it combined. Temperatures climb from 1,900 degrees Celsius near the top to nearly 3,700 by the bottom, a region scientists call the D double prime layer, hot enough to turn your hull to gas before it even has time to melt. Pressure is now over 1 million times what you feel on the surface, enough to flatten a deep-sea submarine like paper. The rock around you churns in massive currents over millions of years. Currents that are quite literally the engine driving every mountain range and tectonic plate on the surface far above you. Outside your capsule, there's no ground anymore, just a dim, glowing haze stretching in every direction and an occasional deep groan of stone, shifting under more pressure than has ever been recorded anywhere on Earth's surface. Nothing about this place was built for anything living to pass through it. And yet here you are, somehow, still moving. If you're still alive at this point, it's not because of engineering. It's because you're piloting something built from materials that don't exist yet, if they're even physically possible at all. 2 layers down, 2 left, and the next one kills faster than anything you've faced so far. Layer 4, the outer core. At 2,900 kilometers down, you cross the most dramatic boundary on the entire planet, dropping straight out of solid rock into liquid metal. The outer core is molten iron and nickel, roughly 2,200 kilometers thick, big enough to swallow a planet the size of Mars whole. Temperatures run from 4,000 up to nearly 5,900 degrees Celsius, hot enough that solid rock from the layer above would already be boiling if it somehow ended up down here. And here's your answer. This is the fastest death on the entire trip. The moment your hull touches the liquid metal, it doesn't crack, it doesn't implode, it dissolves, alloy bleeding into molten iron in under a second, the same way a sugar cube vanishes into hot water. There's a cruel irony waiting for you here too. The churning of this exact liquid metal generates Earth's entire magnetic field, the invisible shield protecting every living thing on the surface from deadly solar radiation. The process keeping you alive up there is the one erasing you down here, instantly, without warning, faster than your instruments could even register the failure. One layer left, and it's the strangest one of all. Layer 5. The inner core. Finally, after roughly 5,150 kilometers straight down, you reach the absolute center of the planet, and physics starts to feel broken. Temperatures sit between 5,200 and 6,000 degrees Celsius, roughly as hot as the surface of the sun. By every normal rule, metal this hot should be liquid, maybe even gas. Instead, pressure here, around 3.6 million times what you feel at sea level, crushes the iron so violently it's forced to stay solid despite heat that should melt it instantly. Scientists call it superionic matter, atoms locked rigidly in place while electrons move freely around them. A genuinely strange state of matter science barely has language for yet. The inner core is roughly the size of the moon, growing about 1 millimeter wider every single year. One thin new layer of frozen iron added to the planet's heart with every trip it makes around the sun. If you actually arrived here, there would be no wreckage, no debris. Nothing left recognizable as a capsule, just matter folded into the same crushing, star-hot solid sitting at the heart of the planet you've spent your entire life walking on top of. And here's the strangest part. Recent research suggests this ball of metal isn't even still, that it may be slowly oscillating, rotating faster than slower than the rest of the planet over decades, meaning the exact object that just erased you is itself in constant, imperceptible motion. In a strange way, it's the only part of this entire trip that feels almost peaceful. A dense, silent, star-hot sphere, sitting perfectly still at the center of gravity of everything you've ever known, utterly indifferent to the fact that anything ever tried to reach it. So there's your answer. Slowest death on Earth, the crust, where a gas pocket might spare you for several agonizing minutes before it finally gets you. Fastest death on Earth. The outer core, under 1 second, dissolved before you even know it happened. Somewhere in between, the mantle spends nearly 20 minutes slowly folding your capsule into nothing, and the inner core waits at the very end, silent and star-hot, indifferent to however you manage to arrive. Next time you're walking outside, remember that a few thousand kilometers beneath your shoes is a ball of solid metal as hot as the sun, sitting under more pressure than anywhere else in the solar system. We've genuinely explored less of what's directly beneath us than we have of the surface of Mars, which honestly says everything about how little we actually know about the ground we call home. The same ground 5 different ways of dying are quietly waiting under right now while you watch this. If you made it this far, subscribe for more videos like this one.